In this module, we're going to talk about advanced calculations and expressions. So a lot of times when you're working on a client engagement, the mathematical requirements may extend well beyond your basic arithmetic. And so what we wanted to do was to give a brief outline of some of the more advanced mathematics that you can do from within the application. And that is the purpose of this module. So if you remember when we were designing the compensation plans, we went into the expression builder. And from within the expression builder, you were able to select rate table result times credit amount. And you might remember that we went to an area within the expression builder that had a table of credit, and we selected credit amount. From within the exact same user interface, you had a number of other options, including the ability to select aggregate functions or numeric functions, etc. So we're going to talk a little bit about those right now. So standard in the GSE demo environments where you've been doing your labs, and standard within the provision environments that our cloud customers get provisioned, the product comes seeded with a number of functions. There are functions for aggregation, functions for comparative analysis, as well as numeric functions. Now what I'll tell you is, and we'll talk about this in a little bit, is that the ability to extend the application to seed additional functions is well within your control and something that you can do during a client engagement as part of the functional setup manager within the setup and maintenance area of the application. So again, I'm going to focus on those functions that are seeded in your provisioned environments, but you certainly will have the ability, and I'll provide instructions in a little bit, to extend the number and types of functions in your environment during an implementation project. So let's actually start off by talking about when you use an aggregate function. If you remember when we were talking about compensation plans, we had the conversation about how are you going to process transactions. Are you going to process them individually, or are you going to group them by interval? Or is your plan component, is that going to be per event or per interval? In both situations, if I was processing transactions individually or my component was per event, that means by definition that I am treating each transaction distinctly or uniquely. Conversely, if I'm grouping by interval, if I'm putting all the transactions in a bucket and only on the last day of the month or the last day of the quarter, I'm dumping those contents out and only looking at them then, in those situations, it then becomes necessary to invoke an aggregate function. Because if you think about it, so if you've been aggregating transactions over a week or over a month or over a quarter, and at the end of that period, you're dumping those contents and you're looking at them, you need to tell the system, what are you looking at? Do you want to sum all the revenue? Do you want to count the number of transactions that were in that bucket over the period? Do you want to find the maximum value, the minimum value? Do you want to find the standard deviation, etc.? So when you're creating an aggregation bucket, as in a per interval, you need to help the system out to tell them what type of mathematical equation do you want to evaluate the contents of that bucket against. And so the list that's displayed on your screen in front of you, these are the aggregate functions that are defaulted within your provision environments. So for example, average is the first one listed, and average returns the average value of whatever attribute you've selected. Count is going to count the individual unique occurrences. Max is going to return the maximum, min is going to return the minimum, etc. And I'll do some working examples on the next slide. So let's say, for example, we're in the printer business, and for a particular rep, for a particular interval, they sold 4 transactions. The first transaction had a value of, say, $120, and it had a cost of $80. And the second one had a credited amount of $200 and a cost of $130. The third one has a credited amount of $250 and a cost of $200. and then the fourth one had a credited amount of $300 and a total cost of $270. So let's work through a few examples. So let's say I wanted to invoke the sum function, and I was going to sum the credit amount. Well, the sum of the credit amount would look at the transactions for the period, and it would return the total from the credited amount column, which would be 120 plus 200 plus 250 plus 300. And so the sum of that would then be $870. If we look at the average of the credit amount, what we're doing is let's take the average of these 4 transactions. So we're summing up the value, which is again $870, and we're dividing it by 4 because there were 4 transactions. And so the average value was, say, $217.50. Then if we look at the next example, we're going to take the max of the credit amount column, and we can see here that the maximum value for that interval was $300. And then if we took the minimum would be the least value within the column, which would be 120. And then finally, maybe we wanted to invoke the count function, and the count function would just count the number of transactions over the interval, which in this example here, it would be 4. So again, fairly straightforward, and if you're ever in the application and you have a question as to what one of the functions means, maybe what does standard deviation mean, or what does median mean, or how is variance calculated, you could certainly navigate over to the application's help. You could certainly cross-reference within the user guide, or if you're anything like me, you might just open up your browser, go to Google, query for it, and you'll have the answer in a couple seconds. And again, that's how aggregate functions work. And as I mentioned earlier, they are required when you're going to build a plan component or a performance measure that is evaluating transactions per interval. Moving on, we also have comparison functions. And what comparison functions allow you to do is it allows you to put 2 variables side by side and do a comparison. The 2 comparison functions that we have are the greatest and the least. Again, where you would compare, for example, the greatest between value 1 and value 2, and it would then return the greater of the 2. Same thing for the least. So for example, in the results section, let's say we're taking the greatest between a field that says credit amount and a constant, which is the number 3. And let's say in this example where the credit amount value is 4, it would then yield us a result of 4 because of course 4 is greater than 3. And then conversely, in the example for the least, if it's between the credit amount and the number 3, where the credit amount is 4, if we're taking the least of 2 values, that would then result in 3. Pretty self-explanatory. Then we have numeric functions. And numeric functions allow us to manipulate the numbers to some level of specificity, or to perform some extra calculation functionality in order to transform that number based on whatever the calculation rules are. So looking at the examples here, the first one that we have listed is absolute value. And so maybe during one of your calculations, you don't necessarily care if it's a negative or positive value, you just want to know what's the absolute value. So in the example we have here, we say if it's the credit amount minus cost, and let's say credit amount is less than cost, so it yields us a value of negative 3.5. If we put absolute value, the result would just be 3.5. Another example is ceiling, and what ceiling does is it rounds it up to the next integer. So let's say, for example, we have credit amount minus cost and it yields us 3.5. If we use ceiling, it would round it to the next whole integer, which would then yield us a value of 4. The opposite of ceiling is something that we call floor. And where ceiling rounded up to the next integer, floor rounds down to the next integer. So in the example we're looking at here, if credit amount minus cost equals 3.5, rounding down to the next whole integer, it would then yield us a result of 3. And then between ceiling and floor is this concept called exponential. And so what this does is in logarithmic mathematics, there's a variable of e, and e equals 2.718288183 to infinity. Very similar for those of you that are familiar with pi, and pi equals 3.1415, etc. In logarithmic mathematics, there is a constant variable e that equals this value. And so if you're working with a client that can only do math with a scientific calculator and insists that the compensation plans for their sales representatives or other people must include logarithmic mathematics, I have good news for you that is supported within the Fusion incentive compensation solution. Then moving on, we also have the moderator where we're going to take the number and then the divisor. And the purpose of that function is that it returns the remainder of a division. So for example, if I had a credit amount of 3 and a divisor of 2, then the result would be 1. The next is power. Power takes a number to a certain power. So for example, 3 to the power of 2 is 9, or 3 times 3. We've basically just squared it in that example. And then round allows us to round a number. So for example, if I had a result that was 3.5121212 and the precision was 2, it would then round that number to 2 decimal points, so it would then just yield me 3.51. The next one is sign, and where absolute value didn't care if it was a positive or negative value, it just returned the number. With sign, it's exactly the opposite. And so what it's doing is it's just testing to see if the number is positive or negative. So let's say, for example, we had credit amount minus cost and that equaled negative 3.51. It would then just yield us a negative 1. This can be very helpful when you're doing calculations surrounding gates or thresholds, or maybe in a lot of industries, they'll want to do running totals and they'll want to know, did the last quarter versus the current quarter comparatively, was it positive or negative growth? They don't necessarily care how positive or how negative, just is the trajectory positive or negative. So again, certainly helpful in situations where you need it. Square root is exactly what it sounds like, which it just takes the square root of a number. So for example, if we had a value of 4, the result would be 2. The next one is something that we call the two-number function. And what this does is sometimes you're going to have a field or you're going to have a value within a field where the information is a string or it's alphanumeric. And as part of your calculation, you may need to convert that alphanumeric number into a numeric number. And there is a protocol to do that within the Oracle database, and it's called the two-number function. That is something that is accessible within incentive compensation. And the next one is a truncate function, where round was rounding up or rounding down based on the precision level. What truncate does is it just cuts it off at that precision level. So for example, if we had a value of say 3.5133 and we have a precision of 1 or to 1 decimal place, then the result would be 3.5. Similarly, instead of it being 3.5133, let's say it was 3.5933. So in 3.5933, what a round function would do is it might round it up to say 3.6, but because it's truncate, a 3.5933 would actually still yield us a result of 3.5. So again, truncate just cuts it off based on that level of precision. And with that said, those are the common numeric functions that you may stumble across either in the GSE environments or in the provisioned environments that you're working on for your customers. So now let's talk a little bit about this concept called if-then-else. Every time I work with a customer, they always ask, can you handle if-then-else logic? Which of course we can, but let me just talk a little bit about that and some of the tactics that we have available in order to enable that. So in order to help illustrate if-then-else, we have this little graphic here of this train going around in a circle. And it says, well, if the light is green, then go, else wait, and then if it's red, then stop. And so within incentive compensation, we actually have a couple different ways to support if-then-else logic. And the one that you would use really depends on your customer's requirements as well as your personal preference. The first tactic available to do if-then-else are via the rate tables and scorecards within the compensation plans. So if you remember when we were in the compensation plans lecture and we were talking about rate tables, we used this slide you're seeing here. Now again, rate tables can have one of four dimensions. They can either be amounts, percents, expressions, or strings. So if we look at the first example here, which is the amount table, we see when units of sold were between 0 and 250, we're going to pay a commission rate of 2. When between 250 and 500, we're paying a commission rate of 4%, and then 500 above, we're paying a commission rate of 6%. If you think about it, this is if then else logic. So if the units sold are between 0 and 250, then pay out 2%. And if between 250 and 500, then pay out 4%. So again, if the criteria of one happens, then do this. If the criteria of another happens, then do that. In the compensation plans lecture, we also talked about the concept of multidimensional rate tables. This is where you can start combining multiple dimensions in order to do some really advanced if-then-else logic. So in the example here on the right, if the license revenue is between 0 and 250, and if it's in the country of the United States, and if it was for product X, then pay 1%. And then if it was between 0 and 250, and if it was in the US, but it was for service Y, then pay 5%. And the same thing if in this range and in the country of Japan, but still for product X, then pay 1.5%, and on and on. So again, depending on preference, rate tables and the scorecards within the performance measures are actually very, very powerful tools in order to give your clients the ability to do some very complex if-then-else logic, but all the while still letting them administer it all within the application through the straightforward user interface that comes with rate tables. Now, if rate tables don't fit the bill, or if the requirements dictate that it has to be done at the calculation level, there is a function delivered standard within the application to handle if-then-else. Now, what I'll say is for those people that are Excel users and do if-then-else, you're probably very, very familiar with the case function. So Microsoft just has a function, they call it case, but what it does, it allows you to do complex if-then-else statements. With Oracle, instead of calling it case, we use the word decode. But like case statements, its purpose is to do if-then-else statements. So to work through an example, let's look at what's on the screen here. So it says, if the product sold equals ABC, then pay them $100. If the product sold equals XYZ, then pay them $150. And then for all other products, just pay them $25 by default. So again, if the product that's sold is ABC, we're going to pay $100. If it's XYZ, we're going to pay $150. And for all other products, just pay $25. So if I was to build that in the expression builder from within the application, I would select the decode statement, and I would say decode, and I would say when the product sold, so product sold is right here, when the product sold equals ABC, then pay 100. When it's XYZ, pay 150, and then for all else, 25. Again, it's different than the way that Microsoft handles it, but different is okay. And as soon as you can pick up the nomenclature to build these expressions, it's actually a very, very powerful tool within the Oracle application. Another seeded option to do if-then-else logic is something that we call the null value function. And that is inherent to the Oracle technology, and it allows us to handle null values. So let's say, for example, I'm working on a calculation, but maybe my data is not pristine, and maybe I have a lot of null values. And maybe I need to account for those null values as part of the calculation. So if we look at this example here, we'll say if the customer name is null, then let's default it with the value of unknown. Otherwise, we're going to use the customer's name. And so if I was going to build that function in the solution, what it looks like is I would use the null value function, and I would say, for the customer name, use the customer name, and it knows that when it's null, insert the term unknown. Again, those are just a few different options that you have available to handle if-then-else logic from within the Fusion incentive compensation application. So something else I want to talk about quickly is the concept of measures, performance measures within the plan component versus something that we call interdependent plan elements. So if you remember when we were building the compensation plan, one of the elements, the what of the what, how, and how much is the performance measure. And in that it says what is the eligible event or activity that's going to trigger a calculation. And within the performance measure, you can do math. And sometimes the output of one performance measure may need to be daisy-chained into the input of another performance measure. And that's leveraging measures. Conversely, maybe one time I am creating a plan component. And let's say the calculated result of one plan component is then going to need to be daisy-chained into another plan component. And maybe the output of that is then going to be aggregated into, say, a third plan component. So the process of daisy-chaining those elements, so one calculation of the calculated result from one is going to feed the input of a calculation of another. That's something that we call interdependent plan components. So one of the nice things about incentive compensation in the paradigm of build once, maintain centrally, but you can use in multiple places, is the concept that you can daisy chain these things together to make them interdependent. And the way that you do that, again, is within the expression builder. When we were building the compensation plans, one of the options on the bottom right of the screen is the ability to select the input or the output of a pre-existing measure or pre-existing plan component and then use that as a variable in your new calculation. Again, just wanted to make you all aware of that. And then finally, in the expression builder, there's also the concept of constants. And constants are, maybe I want to type in a number. I want to type in the number 9. Or maybe I need to type in an alphanumeric string into the calculation. So from within the expression builder, you simply select constants, and then a field pops up, and then you can type in whatever value you need, and then you can add that to your expression. Now, I talked about the seeded aggregate functions, comparison functions, numeric functions, etc., but chances are when you're working on a project, maybe you're not your first few projects, but maybe at some point down the road, you're going to need to add additional functions. And so the power of Oracle on Oracle is that there is a way within the application to register functions available at the Oracle database level. Again, from my personal experience, this is somewhat an infrequent thing to do because I will tell you, most organizations, when they are going to use functions, they're normally things like summing or averaging or taking the max of something, things that we've seeded in the application. But if you need additional functions to be made available within your environment, but they don't exist on what was provisioned for you, but you know that those functions exist on the Oracle database level, you can simply go in and register them and then make them available as part of the expression builder. So what this hyperlink is, or you can do a Google search on your own, is just to query for all the functions that are available within the Oracle database. And chances are you can add them to the incentive compensation expression builder. And then in order to do this, I have these shortcut steps for you on how to add new functions to incentive comp. It involves logging in as someone who has the right privileges to go into setup and maintenance, then query for the task define incentive compensation shared configuration. You're then going to open the task called manage incentive compensation lookups, and then you're going to query for CN. And then from there, you'll see the collection of the aggregate functions, the numeric functions, etc. And product management, as well as the Oracle sales consulting team, does have step-by-step instructions to register those functions within your environment. And finally, I'd like to wrap up this module by talking a little bit about parameterized expressions. In the compensation plans module, as well as earlier in this advanced calculations and expressions module, we often referenced the expression builder as part of the compensation plans work area. Again, the expression builder is a drag and drop user interface where a comp analyst or a business user can log into the application, can drag which fields they want to put into the calculation, and do whatever type of mathematics they deem necessary to calculate a result. And then earlier in this module, when we were talking about the aggregate functions, the numeric functions, the comparisons, etc., that was all still predicated on the idea that the entire calculation is being built within the expression builder. There are, however, occasions when your clients are going to want to create something that we call custom functions. And custom functions are another option to do mathematical calculations, but in addition to using elements within the expression builder, clients or the IT resources at a customer site can actually leverage programming languages like PL/SQL as part of a calculation or as part of a function. This is certainly an option and something that is utilized in a number of different scenarios, and it's something you should be aware of. As an example, let's talk about the concept of a proration calculation. To give an example of what a proration is, think about it as a salesperson that changes position mid-period or mid-quarter. Let's say that typically a sales rep might have a quota of, say, $500,000 for a quarter. But if a rep steps into the position halfway through the quarter, it's not really reasonable to expect them to sell, say, $500,000 worth of business in half a quarter. So what the business would want to do is they would want to prorate that quota based on how much time that sales rep spent in that position. So if that level of sales rep would typically have a $500,000 quota for a quarter, but they're only in that position for half the quarter, then their prorated quota would be half of that, or $250,000. In order to build that calculation, the customer is going to have to evaluate a number of variables. For example, the start date of the interval or the start date of the quarter, the end date of the quarter, the start date of the sales rep or the start date of the sales rep in that position, etc. And what happened in our install base when people started deploying proration, as an example, was that the first customer that was deploying it chose to evaluate the rep's start date as a percentage against the interval so that they could evaluate that that salesperson was in that position for 50% of the interval or 70% of the interval or 20% of the interval. And then that percentage would then be applied to their quota to then offset or to prorate how much quota they were responsible for. Then the next customer came in to do a very similar proration calculation, but instead of doing it based on a percentage, they wanted to count the number of weeks that that sales rep was in that position. So, for example, if a quarter is 12 or 13 weeks, their mathematical calculation required them to know that that sales rep was in that position for, say, 9 weeks, or 9 of the 12 or 13 weeks. Then we had another customer who also wanted to count the distinct units, but instead of weeks, they wanted to count the number of days, and on and on. So what started happening is that we started to see customers building very, very similar, yet different, custom functions that were all roughly achieving the same things, yet they still had some unique variances. For example, like I mentioned in the proration example, some customers wanted it based on a percentage, while other people wanted the output to be in days or in weeks. But despite the approaches being slightly different, the goals of several of our customers were very similar. So when the Oracle product management team started identifying these commonalities, that's how they came up with this concept of parameterized expressions. A parameterized expression is an expression that includes custom functions. But instead of hard coding those variables within the functions, because so many customers are trying to do similar things, product management designed an infrastructure where the customers can pass parameters or pass variables to perform these advanced calculations. And so what's happened is parameterized expressions are now becoming a library They represent the most popular, commonly used custom functions that early customers might have built as a one-off custom function during their implementations. But product management is now standardizing them, introducing parameters or variables so that those customers who are trying to achieve similar results can get a jump start on those mathematical calculations by taking advantage of being part of the Oracle ecosystem. And so with almost every release, this library continues to grow. An example of some of those parameterized expressions that come standard in the product include the list you see in front of you. Now, if you're curious, these are all well documented within the Incentive Compensation User Guide. But I did want to introduce the concept of parameterized functions and include it in the curriculum in this training. The list of parameterized expressions include functions for determining the credit category name, as well as proration elements that I talked about earlier. In this example, or in this list here, we can see proration based on the plan component, as well as participation in the performance measure. There are also parameterized expressions around year-to-date target incentives, as well as functions used to determine the previous interval attainments, date differences, rolling average attainments, and product names. Again, we provide brief descriptions and information on the slides in front of you, but if you want to roll up your sleeves and better understand the workings of parameterized expressions, I'd encourage you to read up on it in the SI wiki that product management maintains or in the Applications User Guide. And with that said, this concludes this module on advanced calculations and expressions.